Hi, Jim Dula here from Horizon AgTech. In this video, I wanted to explain the difference between RGB and multispectral data, how you can use the two, and what are some of the pros and cons between them. So let's jump in from the beginning and start talking about electromagnetic radiation. Electromagnetic radiation is energy, and depending on the wavelength, can be anything from X-rays all the way to radio waves, including what we would refer to as light. The sun emits electromagnetic radiation, or light, mostly around the UV to infrared wavelengths. Human eyes can only see a small section of this light, and that's what we call the visible spectrum. So the sun emits electromagnetic radiation, or light, which comes through space down to hit Earth. Some of that light is absorbed by plants and the ground, and the rest is reflected back up. So when we put a drone up to collect images, we're actually measuring how much light is being reflected back up. When we talk about RGB, or red, green, blue data, we're actually talking about measuring the amount of red, green, and blue light that has been reflected back up to the drone. We measure light in pixels to create an image. Any normal picture you see is an RGB image. Our cameras on our phone take RGB images. Most images these days are made up of millions of pixels. For example, this is an image from the RGB camera on the Mavic 3, which is made up of about 20 million pixels. This is just a zoomed in view of 9 pixels right here. Each pixel contains a red, green, and a blue measurement of how much light was reflected back to the camera. I'll jump over to Pix40 Fields to show you a little bit more detail. Here's a small map of that same image we were just looking at. When I zoom in, I can start to see each pixel. Each pixel is colorized based on the amount of red, green, and blue light that return to the camera. If I right-click on a pixel, Pix40 Fields will actually tell you the red, green, and blue values of each pixel, which can be helpful for some analyses. These values range from 0 to 255. The intensity values are stored as 8 bits or 1 byte for each color channel, meaning you can have 256 possible values here for red, green, or blue, with 0 being no light in that color channel and 255 measuring the highest amount of light. Let's take a look at some applications for RGB imagery in agriculture. Measurements are a big application for RGB imagery. Here is a strawberry block where I've measured the row using the RGB imagery, and Pix40 Fields is telling me that this row is 88.92 meters. RGB imagery can also give you area measurements like paddock size, weed patches, or damaged crop areas. I've created a boundary on this strawberry block here, and it's coming out to 1.863 hectares. You can also use RGB imagery to create boundaries and obstacles. These boundaries and obstacles can be exported out of Pix40 Fields as shapefiles, which can then be imported into spraying and spreading drones or into ground rig controllers. Weed detections are probably one of the best uses for RGB imagery. Here I've used the magic tool in Pix40 Fields to identify green weeds in a fallow paddock. Using this, I can then export spot spraying prescription files for drones or ground rigs. You can also do stand counts with RGB imagery, from early vegetative growth all the way to late vegetative growth, which can then help to make management decisions. So this is a stand count report from a grandma on a corn crop in the late vegetative stage, showing 1,400,398 plants counted in this block. Some crop health maps are available from RGB imagery. Two common vegetation indices from RGB are Triangular Greenness Index and the Visible Atmospherically Resistant Index, or VARI. Pix40 Fields can output both of these for you really quickly. Both give you overlays which show healthier vegetation versus stressed vegetation and bare ground. Now let's switch over to multispectral data. Multispectral data captures a few wavelengths of light our eyes can't see. Typically, multispectral data measures green, red, red edge, and near-infrared light. We can't see red edge or near-infrared light with our eyes, but these wavelengths of light can be useful for analyzing crops. There are several multispectral sensors on the market, but let's take a look at the Mavic 3 multispectral drone. This drone is definitely the best price point on the market at around 9,000 Australian dollars for a full kit with 4 batteries. The M3M can capture both RGB data and multispectral data at the same time. It'll take one RGB image and also generate 4 multispectral images, one in green, one in near infrared, one in red, and one in red edge. Let's jump over to Pix40 Fields and take a look at some multispectral imagery there. So this is a multispectral orthomosaic of that same image or a map. It looks a little different to our eyes because there's no blue light here. So if we zoom in, we can start to see the pixels, and then I'll right click on one, and Pix40 Fields will actually tell me the red, green, red edge, and near infrared values for each pixel. Some of the applications for multispectral data include, and probably the biggest deliverable from multispectral data is NDVI. So NDVI is a vegetation index, which means it uses a formula to calculate a value from the multispectral data. The formula is near infrared minus red divided by near infrared plus red. This gives you a value between -1 and 1, which typically indicates how much chlorophyll is in that pixel or its vegetative greenness. It can give you an idea of how well a crop is doing in different parts of the paddock. Strong, healthy vegetation usually shows up around a 0.9, so it would be the brighter green area. Stressed vegetation would come in lower and be represented in yellow, orange, or red all the way to bare ground. Keep in mind these representations are based on how you adjust the histogram for the NDVI map. Once you have an NDVI map, you can use it for a variety of things, including a variable rate fertilizer prescription map. So this one has 5 zones based on NDVI values where you can adjust the rate by zone and export this prescription file to a ground rig or a drone. NDVI can also be used for green on brown weed detection. I like looking at NDVI in grayscale because it makes it really easy to see the green weeds in the fallow paddock. So the green weeds are the bright white dots here. And then you can transform this into a prescription file for spot spray emissions. Let's go back and talk a little bit about data volume. So when deciding to use RGB imagery versus multispectral imagery, remember that the multispectral data is going to be a much larger data file. So it's going to take longer to move those images off the SD card and to process them and stitch them together into one orthomosaic map. This one RGB image is 10.8 megabytes, and the frame is larger, so it covers a lot more ground than multispectral images. The 4 multispectral images combined here are 38.4 megabytes and cover less ground than the RGB image due to a smaller frame. So you have almost 4 times the amount of multispectral data as RGB data, capturing a smaller area. When you scale this up, the file sizes can really impact processing times. Let's say you mapped a paddock and got 2,000 RGB images. That would be 21.6 gigabytes of data. If you collected a multispectral data set on that paddock, you're looking at least 8,000 images and a file size of 76.8 gigabytes. That means longer to move the data from the SD card to the computer and longer to process the data. Price point also comes into play, which is of course very important. For example, the DJI Zenmuse P1 RGB sensor, which flies on the M350, would run you about 11,400 Australian dollars, including GST. The MicaSense Altum PT multispectral sensor would run about $30,000, including GST, and has a smaller frame, so it would take longer to map the ground, and it would generate larger data files to cover the same amount of ground. So due to file size and cost, I always recommend trying to accomplish your project with RGB data first, and then only collect multispectral data if you really need to. That's just a few things to consider when looking into RGB and multispectral data for agricultural mapping. If you have any questions, just drop them in the comments or check out our website at horizonagtech.com.au.